Hello and welcome to my YouTube channel. Today I will begin with the special cases of connected motion. In the last class I discussed about the connected motion of a pulley over which a massless string was passing and two masses M1 M2 were attached. Now, two special cases, they are being described here. One case where a table is here, a pulley, massless pulley is over here, a mass M1 is being attached by a massless string and masses M1 M2 are attached to the ends of this string. We have to find the tension and acceleration of this string. This is the first special case. In the second special case, we can make here a diagram like an inclined plane where a pulley is attached here, massless pulley, a mass M1 is attached by one end of a massless string and another mass M2 is attached to the other end. This is the pulley. Now another case we can also consider. That case is like this here, and the pulley is over here attached by a string passing over it, two masses M1 M2. They are just lying on the surface, and the surface are taken as a smooth surface. In all three cases, we have to find the tension and acceleration. So let us consider one by one of each cases. Case number 1. Let the tension throughout the string be capital T. Since the string is single string, massless string, and massless and frictionless pulley is here. The mass M2 let is greater than M1. So M2G will be the weight that will pull this body, this mass, and the tension will be along upward direction, and here the tension will act along this direction, and this tension will pull M1 along horizontal. This weight M2G will pull vertical downward direction. The equation of motion for each masses can be written as here. I can write here like that. The equation of motion for the equation of motion for M1, here we can write here T is equal to M1 into A acceleration. This is the equation 1. Similarly, we can write the second equation for the second mass, that is M2. Here M2G, here I can write motion of M2, that is the equation of this one can be written as M2G minus T, that is M2 into A, equation number 2. We can put the value of T in equation 2. so that we could get acceleration A. So by 1 and 2, putting value of t into, that is m2g minus t means m1a, that is m2a, and here we can write m1a plus m2a, and that is m2g is equal to, common is m1 plus m2 into a, the common is a, that is a is equal to m2g by m1 plus m2. This is the acceleration, meter per second square, if it is given in meter and second. So this is the acceleration. We can find t, putting the value of a in equation number 1. We can get the value of t. So putting a in equation 1, we can get the value, and that value can be calculated like this. 1 imply t is equal to m1 into a. A means m2 g divided by m1 plus m2. m1 plus m2. This is the tension in the string, Newton. So we have calculated tension and acceleration in this case. Now let us calculate the tension and acceleration in the second case. What was the second case? In second case, there was an inclined plane. Let us make the diagram again. This is the inclined plane at angle theta. A mass m1 is here, and another mass m2 is here. m2g is the weight that is pulling the mass m2, and the tension will act along this direction. The tension will act here along this direction. So resolving the weight m1g into two directions, along this direction, along this direction. This is m1g. If it is theta, that means it must be theta. So m1 g cos theta, this will be the one resolved part, and m1 g sin theta, that will be another. So we can write here the equation of motion for m1. The equation of motion for m1, that can be calculated as t is pulling along this inclined plane in upward direction, along the direction upward, that is t minus m1g sin theta. This will be m1 into a, the acceleration. This is the first equation. And for the second equation, that is for m2, the equation of motion, that can be written as m2g minus t will be equal to m2 into a, equation 2. So solving 1 and 2, solving means adding 1 and 2, we can get the required value. That means if we add equation 1 and 2, then we can write here, adding 1 and 2, we can get t minus m1g sin theta is equal to m1a, and m2g minus t is equal to m2a. If we add it, tt will be cancelled, and therefore m2g minus m1 g sine theta, that will be equal to m1 plus m2 into a. Now this a can be written as a is equal to m2g. You can take common g here, m2 minus m1 sine theta into g divided by m1 plus m2. We can again check the equation. T minus m1 g sine theta is equal to m1a, t minus m1 g sine theta m1a. The second equation m2g minus t is equal to m2a. If we add it, tt will be cancelled out, and now m2g minus m1g sine theta here. If we take common g, then m2 minus m1 sine theta into g by m1 plus m2. This is the acceleration. So once we have calculated acceleration a, then we can put the value of a in either of the equation and we can get the value of t. Now the another special case, that is motion on the inclined plane on both sides, will be discussed in the next class. So wait for that class. In that upcoming class, I think some more concept will be discussed. So please like, subscribe, so that you can get my upcoming videos and you can get benefit of the concept. Okay, thank you.